Of your packet. We're going to split up 5-2 into 2 days. There's a lot of stuff in here that we're going to be looking at. Today, we're going to talk about congruent polygons. And so, as we get more into the chapter, it'll just be focused more on triangles themselves. But today, it's going to be triangles some. It's also going to be some rectangles or some other figures as well. So it's not just going to be all triangles today. But when we look at congruent polygons, now when I look at these two here, are these two polygons congruent? What does it mean to be congruent? We talked about that a lot last chapter. Same shape and same size, right? So are these two triangles congruent? No. Okay, and it tells me right here that the triangles are similar, and so based on what we talked about last chapter, okay, if they're similar, that means they have the same scale factor, right? They're both multiplied or changed by the same enlargement or reduction value, same k value. And we don't necessarily have to find out what that number is, even though we could, right? Like this one here would be pretty easy. How much bigger is 150 than 75? Yeah, this is 75 is half of 150. So what do you think x would be? No, it would be half of 18, right? Sometimes it's not always that easy. So if it's not always that easy, one way that we could do it is we could say x is to 18, because those are the two sides that match up with one another, as 75 is to 150. And you could just set up what we call a proportion. Okay, so when I set up the proportion here, then I can cross multiply and I can solve. Darston, what you doing? Okay. So let's cross multiply and divide. And we should get 9. Okay, now, that's a little bit harder way of doing it than what we talked about before, but it's not always going to be double or triple, okay? What if it was a scale factor of like 3/4 or something like that, okay? But if it's a nice scale factor of a nice whole number, then we could either multiply by 2 or divide by 2 or whatever we need to do to get from one to the next. Okay, same thing here. The biggest thing is that when you set up a proportion, you have to match up the two sides that go together, okay? So obviously here, this is my long side, this is my long side. So I'm going to start with that first. I'm going to say 115 over 5. And then we got to make sure we go in the same direction. I'm going to go bottom side to bottom side, but I'm going to go big triangle to small triangle. Big to small, using the same two sides that match up. That's extremely important that we use the same two sides that match up with one another when we do that, okay? And we've solved proportions before, so that part's not going to be new to us. We go back to Algebra 1 with those. 5x equals 345, and then 345 divided by 5. What do we get? That would be our answer. Okay. You could do the same thing here again. You could do a scale factor, and you could figure out how much bigger is 115 than 5. So I could take 115 divided by 5, and I could do it that way. So there's several different ways that you could get to that result, depending on what your scale factor is. So that's going to be kind of one of the things that we're going to be looking at today. Except today we're going to look at parts of a figure. Corresponding parts of a figure are congruent. So if we say that corresponding parts of congruent figures are congruent, this means that corresponding sides and corresponding angles are all congruent. If I tell you that two figures are congruent, that means all the parts that match up would be congruent as well. So if I have a triangle that's congruent to another triangle, then we have 3 pairs of sides and we have 3 pairs of angles that match up. If I had a 4-sided figure, then I'd have 4 sides and 4 angles that match up with each other. Okay, but we have to know they're congruent first. If we know they're congruent, then we know all their pieces are congruent. Okay, so on this first one here, this is what we call a congruence statement. We are stating that these 2 triangles are congruent. Triangle ABC is congruent to triangle DEF. And here's that congruent symbol again that we've seen over and over again. Okay? So we're stating that these 2 are congruent. Now, here's the very first thing I'm going to tell you. I'm going to talk about this a lot as we go throughout this chapter. But A is the first letter here. It's got to match up with D. Don't always look at the picture to know which way it matches up. Okay? Because here the 2 triangles are sitting a little bit differently, right? And so some people might say, oh, A, maybe it matches with F. You can also look at the markings, but we don't always have markings on there. So if I don't have markings, then I really have to pay attention to the congruent statement. First letter matches with first letter, second with second, third with third. Those are the pieces that match up with one another. Okay? And we'll talk about that more as we go throughout the lesson today. This one, it's a little bit easier because everything's already marked for us. We already have a picture, everything on the pictures are marked, and so it makes it a little bit easier. Okay, so first thing here is it says, identify the corresponding sides of the given figures, okay? And so what we'll say here is, I'm going to start with BC. BC would be congruent to, and we have to look at, BC has 1 mark on it, EF has 1 mark on it. The 2 that have the same marking are congruent. Okay, then I'm going to go to the one that has 2 markings on it. So I'm going to go to AB. AB is congruent to ED. What if I said DE? Would that be okay? ED or DE? When I name a segment, it doesn't matter. If I'm naming the triangle, then that would matter, and we'll talk more about that. Okay, and then the last side, the third side, AC, is congruent to DF. Those are the 3 sides. We have a triangle, so we have 3 sides, and those are the 3 sides that would match up with one another. We don't know the actual length, but we know they're congruent. Okay, corresponding angles. Once again, because the markings are on the picture, then it's pretty easy to determine what goes with what. Because the ones that have the same marking are the ones that are congruent. So I'm going to say angle A is congruent to angle D. I'm going to say angle C is congruent to angle F. You guys need to quit talking, please. And then finally, angle B is congruent to angle E. Those would be the 3 that would match up, listed in any order. Okay, and it goes to the same thing here as my statement: A to D, B to E, and C to F. Those are the pieces. Those are the parts that match up. Okay, if I ask you to write the congruent statement another way, the congruent statement can be written a lot of different ways. Right now it's written ABC. Okay? So let's rearrange the letters a little bit. Instead of ABC, what's another way that I could write the letters? CBA. Okay, let's go backwards. CBA. So if that one goes backwards, then I have to do the same thing for the second triangle. I would say triangle FED. And the reason why that's really important is C still matches with F, B still matches with E, A still matches with D. But there's lots of different variations that you could do here. I could do triangle BCA. And BCA would be congruent to triangle EFD. So when I rewrite these, okay, and I could keep going if I wanted to. I'm just writing a couple of them up here. But how you write the triangles and the order that you put them in is extremely important, okay? Can't stress that enough. It's extremely important that we put the letters in the right order so that way the pieces are matching up with one another. So that if somebody wants to know what two triangles, what two pieces match up, they can look at your congruent statement and immediately know these are the two pieces that will go together. Okay? All right, on this one here, this one's a little bit more difficult because we have a four-sided figure. So that means we have four sides and we have four angles, but there's no markings on the picture. And we can't just go off of what it looks like. We have to go off of our statement. This statement right here is everything, okay? And so there's a couple different ways that you could go about it, but I'm just going to kind of go one step at a time here. We're going to identify all the congruent parts. So that means sides and angles. So we're going to start with AB. And the only reason I choose AB is because it's the first two letters in that first figure. Okay, what's the first two letters in the second figure? CD. Okay, so AB is congruent to CD. As I mark these, then I would encourage you to mark it on your picture as well, just like the last one was, except the last one was already marked for us. Okay, then we're just going to go through the letters. The next two letters are BG, the second and the third letter. And I'm going to say BG is congruent to what segment? D. Okay. Second and third on the second picture. So BG, I'm going to mark that with two markings, is congruent to D. Okay. It's really kind of hard to tell just by looking at it which pieces match up because it's not sitting the same way. And we don't know the lengths or anything like that. So that's why we have to use the congruent statement. Okay, then we're going to go GH is congruent to EF. Okay, and then finally, now be careful here because we're going to skip, right? It's first and last. Or you could just look at the picture and say AH and FC are the two that aren't marked yet. So we're going to say AH is congruent to FC. Those are our three sides. Okay, angle would be a little bit easier here because angle, we only have to talk about one letter. Okay, we don't have to name three letters when we do it, or two letters. One letter is enough. And so the reason why this is a little bit easier is because A is going to match with C, first to first, right? So angle A is going to go to angle C. Angle B is going to go to angle D. Those two would be congruent. We don't know the actual measure of it, but we know that those two are congruent. And we just keep going. We're going to have four angles because we have a four-sided figure. So G is going to go to E, and H is going to go to F. Okay, so essentially, if I have a four-sided figure, I have 8 pieces that have to be congruent. I have 4 sides and I have 4 angles. So I have 8 total pieces that must be congruent. If I have a 3-sided figure, I'm going to have 6 total pieces, 3 sides and 3 angles that are going to be congruent. Okay, on this one here, we are trying to find the value of x and y. Okay, trying to find the missing value. And you got to be really, really careful here about what matches with what. And once again, I'm going to stress this over and over again. The statement is what we have to go off of. Don't just try to look at the picture and guess what matches up. Because right now, nothing is marked on the picture. And so trying to decide what side goes with what side and what angle goes with what angle can be really, really difficult to do. So don't just guess, okay? The picture and the statement tell me everything that I need to know. Okay, so let's say, I don't want to start with this because it has 2 variables in it, right? It has a y and an x. I don't want to start with that because we have two things we have to find. So the one that I'm going to start with is 2x minus 4, because it has just an x in it, right? And that is segment QR. So we know that QR is 2x minus 4. QR is the last two letters of this picture, right? Of this figure. What's the last two letters of the original figure? FG, okay? So QR and FG are going to be the same. So QR is going to be congruent to FG. FG is 12. So if those two are congruent, what's that also mean? What's it mean to be congruent? They're the same. They're equal, right? So what I can do then is I can say 2x minus 4 equals 12. And then I add 4 and divide by 2. Okay, the directions are asking me to find x and y. We've found x. Okay, the other variable, the only place that we see a y is right here. And that is representing an angle. And which angle is it representing? Which one? Q, yeah. So angle Q is 6y plus x. Okay, what angle does Q match up with? On the first figure. Yeah. Q is the third letter in this one. F is the third letter in this one. Okay, third to third. That's all it takes. Match up whatever place they're in. If it's the third letter in the statement, it matches up with the other one. So angle F is 68 degrees. So we're going to rewrite 6y plus x equals 68. Okay, and we do have two variables here, but what did we already find? We already found x, right? And we said x is 8. So x can be replaced with 8. So 6y plus 8 equals 68. Plug it in. Now we solve. 6y equals 60. And we get y equals 10. And that would be our two variables. Okay, questions on that? Okay, just looking at the statement is the part that's the most important part. Okay, looking at the statement, because as I look at this picture, would you guys agree that it's really hard to determine what two pieces match up just by looking at the picture, since nothing's marked, right? If I said, what side does RS match with? Sometimes we might be able to have a pretty good idea, but we don't really know for sure, right? This statement right here is where we're going to get that information. I know that RS is going to match with first and last. So that would be GD. Okay? And you don't have to mark the entire figure, because we didn't need the entire figure here. We just were looking for specific parts of the figure. But that's where we're going to get our information. The statement tells me everything I need to know. Angles and sides. All right. On this one here. Find the value of x, okay? We only have one x in the problem, and it's 4x plus 5, right here. Okay, 4x plus 5 represents what? Okay, what does it have? It has an angle measure, right? And if it has an angle measure, what's that mean? It's one of my angles, right? If it's a side, then a side is probably going to be labeled, like if I said this is 4y, then I'm going to probably put the side on the outside, okay? The angle is usually going to be on the inside of the figure. So maybe not always, but typically, the real key here is that it's degrees. Degrees means it's an angle. So which angle does 4x plus 5 represent? Angle H. Angle H equals 4x plus 5. Once again, just by looking at the picture, I know that angle H has to match up with one of these two, but in order to determine exactly which one I want, H is the last letter in this statement, so H is going to match with what? F, okay? Angle H is congruent to angle F. We know that F is how many degrees? 105, okay? So we're going to say 4x plus 5 equals 105. And then we're going to subtract 5 and divide by 4. Okay. Once again, pay attention to the directions of what's going on. And if it says find the length of the side or find the angle measure or something like that, then we may have to plug it back in. Okay? But in a lot of cases today, we're going to be finding X and Y. There was one question yesterday that a lot of people were struggling with, and it was the story problem about the wording. If I say 2 times the difference if I say 2 times the difference of x and 8, this was very similar to the problem yesterday. How do I write that as an expression? What does difference mean? Subtraction. So I'm taking x minus 8 because difference means subtraction. Okay? If I want to double that or take twice of that, what am I going to have to do? I got to multiply by 2. Is it okay to just put 2 right here? Does that multiply, does that take 2 times the entire thing? No. So the part that was a little bit tricky yesterday is you have to put that expression in parentheses and then double it, and then take it twice of it, okay? So if you had problems with that, that might help you with that one. If you haven't got to it yet, maybe that'll help you with it. If you need help with that, let me know and I can help you with it. Okay, just wanted to mention that because a lot of people were struggling with that one yesterday.